Ωραία. Καλώς ήρθατε όλοι. Εγώ μόλις ήρθα με το Στέλιο από ένα πολύ ωραίο Innovative Greeks podcast που κάναμε μια πολύ ωραία συζήτηση. Έχουμε ακόμα το make-up, οπότε μας παρεξηγήστε. Δεν προλάβαμε καν να το βγάλουμε, γιατί η Μάγκη φώναζε ότι έχουμε αργήσει. Λοιπόν, τώρα τον Στέλιο Παπαδόπουλο, νομίζω όλοι, φαντάζομαι για να είστε εδώ, ξέρετε πολύ καλά ποιος είναι. Τον έχουν ονομάσει και πατριάρχη της βιοτεχνολογίας στην Αμερική. Τον έχουν ονομάσει αρχηγό της ελληνικής βιοτεχνολογικής μαφίας επίσης, the Greek Biotech Mafia στην Αμερική. Και σίγουρα αυτό που του έλεγα σήμερα το μεσημέρι που βρεθήκαμε είναι ότι οπωσδήποτε και αυτός και η λαμπρή παρέα που έχει φτιάξει στην Αμερική, γιατί αυτός ήταν ο πρώτος που οργάνωσε όλους αυτούς τους ανθρώπους, από τον Αλμπέρτο Μπουρλά μέχρι τον Σκάγκο, τον Γαλακάτο και όλους αυτούς τους λαμπρούς Έλληνες σε αυτό το χώρο. Σίγουρα η επίδραση που είχαν πάνω στον κόσμο, αν αρχίσουμε με τη μεγάλη εικόνα, σε θεραπείες όπως της σκλήρης καταπλάκας, το Alzheimer's, τώρα λέγαμε ότι σήμερα περιμένουν το approval του νέου φαρμάκου, η Biogen, νευρολογικές παθήσεις, το εμβόλιο του COVID. Είναι άνθρωποι οι οποίοι η επίδραση αυτών των λίγων Ελλήνων πάνω στη ζωή όλου του πλανήτη είναι πάρα πολύ μεγάλη και θα τολμούσα να πω ότι σε κανέναν άλλο τομέα ιστορικά η Ελλάδα δεν είχε τόσο μεγάλη επίδραση όσο στην περίπτωση του τομέα αυτού. Οπότε αυτό είναι η μία πλευρά του νομίσματος. Η άλλη πλευρά του νομίσματος που νομίζω ότι μας αφορά όλους είναι τι επίδραση έχουν όλοι αυτοί οι άνθρωποι πάνω στις προσδοκίες, στα όνειρα, στις μελλοντικές, αν θέλετε, εταιρείες που θα δημιουργηθούν από την Ελλάδα ή από Έλληνες εκτός Ελλάδος. Και νομίζω ότι αυτοί οι άνθρωποι έχουν μια βασική, αν θέλετε, επίδραση πάνω στις επιλογές που κάνουν πλέον οι νέοι Έλληνες επιχειρηματίες. Δεν νομίζω ότι είναι τυχαίο ότι το 1/4 των εταιριών που βλέπουμε στο Elevate Greece είναι στο χώρο των επιστημών υγείας και είναι και κάτι το οποίο θα έλεγα ότι μάλλον δεν το περιμέναμε κιόλας πριν 10 χρόνια. Οπότε αυτό το οφείλουμε αρκετά σε αυτήν την ομάδα ανθρώπων, γιατί ενέπνευσε προφανώς πολλούς νέους να επιλέξουν αυτό τον αντικειμενικά δύσκολο δρόμο. Έτσι. Δηλαδή, είναι πιο εύκολο να φτιάξεις software και πιο εύκολο να κυνηγάς clicks από το να μπεις σε μια πάρα πολύ δύσκολη περιπέτεια από να ψάξεις την έγκαιρη διάγνωση του Πάρκινσον μέχρι καρκίνους σε σύντομη διάγνωση, σε τόσα άλλα πράγματα σε αυτό το τομέα. Οπότε, νομίζω ότι είναι και άνθρωποι οι οποίοι και τη χώρα έχουν βοηθήσει πολύ με το καλό τους παράδειγμα, κατά κύριο λόγο, σαν role models, αλλά σίγουρα και τον πλανήτη. Τώρα, είναι μεγάλη μας τιμή που τον έχουμε τον Στέλιο εδώ σήμερα και ο ΣΕΒ στο τμήμα καινοτομίας του έχει δώσει πάρα πολύ μεγάλη έμφαση σε αυτό το τομέα και έχει κάνει, νομίζω, αρκετά πράγματα μέσα στο σύντομο διάστημα που υπάρχει αυτή η Επιτροπή. Έχουμε προσπαθήσει να κάνουμε κυρίως 3 πράγματα. Να καταλάβουμε λίγο πώς επηρεάζουν την Ελλάδα οι μεγάλες τάσεις παγκοσμίως και αν υπάρχουν κάποιοι τομείς μέσα σε όλα αυτά τα πράγματα που συμβαίνουν, στους οποίους μπορούμε εμείς να βρούμε τη θέση μας και να συνεισφέρουμε. Αυτό είναι το πρώτο. Το δεύτερο, θα έλεγα, είναι ότι μιλάμε για ένα ρυθμιστικό, αν θέλετε, περιβάλλον πάρα πολύ περίπλοκο. Παντού και στην Ελλάδα. Και προσπαθούμε μέσα από το ΣΕΒ, όπως έχουμε κάνει στο παρελθόν και σε πολλούς άλλους τομείς, πρώτα απ' όλα να το καταλάβουμε εμείς οι ίδιοι και μετά να είμαστε σε θέση να το συζητήσουμε με αυτούς που νομοθετούν. Αυτό δεν είναι τόσο απλό και σίγουρα είναι πιο αποτελεσματικό όταν δεν προέρχεται από συνδικάτα, να το πω έτσι, συνδικαλιστικά όργανα, όπου πάντα το κράτος θα τους αντιμετωπίζει και καμιά φορά και σωστά με κάποιους δισταγμούς, ότι κάνουν κάτι για το δικό τους συμφέρον. Ο ΣΕΒ ευτυχώς έχει καταφέρει να είναι ένας πολυσυλλεκτικός φορέας, θα έλεγα ένας σπάνιος θεσμός για την Ελλάδα, που έχει υψηλές δόσεις, να το πούμε, αλτρουισμού ως προς τα μέλη του και την ίδια στιγμή βάζει το καλό της χώρας πάνω από τα στενά, αν θέλετε, στενά ενδιαφέροντα των μελών του. Οπότε είναι ένας κατάλληλος παίκτης για να παίξει ρόλο στο ρυθμιστικό κομμάτι. Και το τρίτο θέμα είναι φυσικά το θέμα των επενδύσεων. Τώρα, το θέμα των επενδύσεων, εντάξει, είναι πολύ γνωστή η επένδυση της Pfizer, είναι γνωστές και άλλες που έρχονται. Είναι πολύ γνωστές επίσης, νομίζω, και οι ελληνικές φαρμακευτικές εταιρείες τι έχουν αρχίσει να κάνουν. Έχουμε εδώ και εκπρόσωπους της Ελπέν και άλλων φαρμακευτικών. Νομίζω υπάρχει μια αναγέννηση στον τομέα. Αυτό το οποίο εγώ, τουλάχιστον ερχόμενος από το χώρο του software, έχω αντιμετωπίσει είναι το όνειρό μας έγινε πραγματικότητα. Δηλαδή, πριν 10 χρόνια ελπίζαμε να υπάρχει ζήτηση για πολύ καταρτισμένους software developers και product designers και τώρα έχουμε το ανάποδο πρόβλημα, ότι η ζήτηση υπερβαίνει το ταλέντο, την προσφορά ταλέντου. Οπότε, εμείς στο ΣΕΒ κοιτάμε και το, αν θέλετε, σύντομο διάστημα αυτό, τι κάνουμε από πλευράς επενδύσεων, αλλά από την άλλη, πώς δημιουργούμε και μια ροή ταλέντου για να στελεχώσει αυτές τις εταιρείες. Λοιπόν, δεν θέλω να σας κρατήσω άλλο, να περάσω τη σκητάλη σε εσάς για να μιλήσετε με το Στέλιο απευθείας. Ευχαριστώ πολύ.
Thanks all for being here, and my name is Labros Kurtis. I start companies for a living. With me, Stelios Janis, who just came from San Francisco to take up a very important mission to start an innovation hub called the Athens Life Tech Park, and we wish him good luck with this. I'll give you an agenda of what we're planning to discuss today, and we're going to share an infographic that the folks at Sínδεσμος των Μηχανιών have put together on the ecosystem and where things are. We're going to talk a little bit about development of a life sciences ecosystem country-wise. We're going to do a case study, which is Athens Life Tech Park. We're going to also discuss about the financial environment and how this is affecting investment in innovation, how things are changing with all these changes in the economy. Then we're going to talk a little bit about the relation between startups and pharma, and how do these organizations can work together. And we have a bunch of questions, and thanks everyone for submitting those, ranging from specific fields of innovation and where things are moving. We do have a few personal journey questions for you if you're up to. So let's start. If we can show the first infographic. So this is, I just saw it yesterday, and it's impressive to see all this information together. The pharma is one of the powerhouses in Greece, and it's about 11,000 people are working in pharma. An unprecedented amount of investment is flowing towards pharma these days. I have to stress that these figures mainly affect manufacturing and sales and generics. A small part of that is innovation, so let's keep that in mind as we go on in the discussion. And the next slide has to do with the startup ecosystem that is forming. And over the past 3 or 4 years, we've seen about 100 startups being founded in life sciences, raising about 130 million. And this is all new stuff. This is all new stuff. And I want to focus on the bar chart below, where we see the stratification of different startups, and the vast majority of new startups are in the digital health space and in diagnostics. So let's also keep that in mind as we design the discussion forward. So before I start, I want to make sure that this is a discussion, so everybody that has questions, please raise your hands. And we did incorporate some of your questions in the flow of this discussion. So, Dr. Papadopoulos, thank you so much. The first topic is development of a local ecosystem, healthcare ecosystem, and we know that the major centers of innovation are in Boston, in San Francisco, in Basel, and they will remain to be there. I wanted to switch the discussion into these secondary centers of innovation, and I wanted to take an example in Ireland, and I've been studying this case study. And this is a hub, for those that don't know, for Boston Scientific, for Medtronic, for Johnson & Johnson, mainly medical devices. But recently I saw my ex-boss, Dave Ricks, inaugurating a biologics center for $1 billion in Limerick. So I looked up Limerick. And it's a town the size of my hometown, Larissa. And it's got a university that's about 100 positions lower than Aristotelio. It's got an airport that has 4 times less traffic than Macedonia. They all speak fluently English, of course. They're 4.5 hours from Boston. That's a big advantage. And they did have a very generous tax system established early on. But so did Bulgaria and Cyprus, right? Other countries did similar stuff. But Dave Ricks didn't go to Bulgaria. Now, what's surprising is that in Ireland, the per capita is almost twice as much as the average US, and 5 times that of Thessaloniki. So why did Dave Ricks go to Limerick? And you'd share the board of a big pharma tech. What would you tell your board to convince them to go to Limerick or Larissa?
So let's let's define some things. I know nothing about medical devices, so I will not comment on that. I know a lot about things about drugs. I can talk a lot about drugs. Ireland is a very good example, and let me just, as an aside, Mr. Kontosamanis is here, who in fact it's like the reason I've become popular now in the Greek world is because after an article in the paper, he found me and dragged me over to go to Maximo and meet with the Prime Minister, and we started doing work, and we submitted a pretty elaborate proposal to the Prime Minister of what Greece could do in the biopharma space that's more or less innovative. So Ireland was a very good case study in that because they've done it right, as has Singapore, for instance. So what have they done right? They started 30, 40 years ago as a tax haven. They had the advantage of language and a reasonably well-trained sales force, broadly speaking. And as they keep on building more and more facilities, then the management and the employee base enlarged, that became good and better and better. And at this point, you have, if you read the promotional materials from Ireland as to why you should go there, you become pretty convinced it's a preferred destination. They've got lots of advantages. You correctly pointed out that the tax thing is no longer the driver. It's a driver, but it's not the biggest driver. Now the biggest driver is the existing infrastructure, the existing ecosystem. And one other thing, to be sure we all understand this, the bulk of what goes on in Ireland is manufacturing.
Yes.
It's not innovation.
That's right.
There's a huge difference.
That's right.
Huge difference. You know, innovation, look, here's what the issue is. If I need to perform a business function of reasonable sophistication, but that many people could do that, then I'll go for the low-cost manufacturing, low-cost producing, low-cost sales support place. And I could go to Poland, I could go to India, I can go to Ireland, I can go to Greece. If I want to innovate, if I want to develop a drug for a disease for which there's no alternative, then I cannot say, you know, if I got some pretty good guys and I pay them less, I'll still get there. Then I'm going to get there. Innovation can only be carried out by exceptional, outstanding people who work in conjunction with each other, equally outstanding, and with a lot of money. To give you an idea, you talk about in the infographic, 24 startups raised 135 million euros. A single Series A for a startup in biotech in the US is now $150 million. Yeah. So you can see the difference.
Right.
And if that money was put into innovative science to develop drugs, I would question the sanity. what we lack here, and that's what we've stressed repeatedly with the Prime Minister and the government, is we lack an academic system that has the best of scientists of the world. Why is Boston a hub? Because they got MIT and Harvard, and then a bunch of money guys got there because they saw the action, and that's how it became this place of proliferation of ideas and companies. And small companies get bigger and bigger, and even the big pharma companies have gone there. San Francisco, San Diego, even in the US, the state of Nebraska, the state of Idaho, they try to get into the game. They couldn't.
They couldn't.
I don't want to make sure there's nobody here from University of Idaho, but I don't know of any great discoveries out of university. There may be one or two, but I don't know. But that's the point, is the critical mass of super talented people who are asking critical questions. And I think what we need to do here to do it right is reform and appropriately fund basic research at the academic level so we can begin attracting some very talented people. The people we have here are very good. Some could even have reasonable careers abroad, but very rare that we have a truly outstanding scientist working in a Greek university, full speed ahead, who can compete with a team. And they're not teams, they're big teams at Stanford or Harvard or MIT or Hopkins or Memorial or whatever. So we need to focus on the education, and then we need, through appropriate, and by the way, I would not suggest government funding and subsidy. What I would suggest is government reform in the obvious things everybody's talking about: the legal system, the telecom system, the power grid, simple things. And then appropriate tax packages that would be compatible with the international minimum tax rates, that you can bring in people to do stuff they could do in Ireland or Singapore. And you can see even Pfizer is setting up manufacturing facilities in Ireland. Pfizer. They already have a site in Thessaloniki, as you all know. It's probably, slightly north of 1,000 people there. Yeah. But they're not discovering drugs. They're doing procurement, they're doing other services, clinical trial support. These are very competent people costing less than they would have in the US. There's nothing wrong with that, particularly if it provides the management talent base that will enable you later on, once you get the great idea from a university, to go there and do a true innovative biotech startup.
So would you say that the way to become an innovation powerhouse would be to have those companies establish their manufacturing or their services and then let it mature until people will spring out, essentially, and create their own?
Well, it's not, these people aren't going to create their own. A manufacturing executive is not, a state-of-the-art research scientist. These guys usually are in universities, okay? So you need to do things in parallel. Near term, for tax revenue generation, for employment, for all sorts of other good things, you do a number of these businesses that can be done in many places in the world, and we offer the attraction of a reasonably low cost structure, good climate, strategic location, access to ports, airports, all these things matter. But at the same time, if we don't focus on research at the university and institute level to get to the point that we'll have a great team from the US come more than once, several, to establish foothold here and do the work, and then maybe one of them will come up with something. Because there are many smart people in the US. Not all of them come up with great ideas for drugs.
Do you feel perhaps Israel presents a better example of an ecosystem that's a little bit closer to what we are or what we should be doing here?
Well, to be honest with you, in the healthcare space, for exactly the reasons I outlined, Israel is just a shade better than Greece. But there are not a whole lot of drugs. I can tell you this. I don't suppose there is a single drug in global use in an important disease that has come out of a Greek university or company. Now, there are a handful out of Israel. Yeah. Israel has done very well in the high-tech space. Yeah. That's a very different business. Different skill set, different requirements, different capital needs. And of course, they also got the benefit when Russia opened up. A whole lot of super smart scientists emigrated to Israel. But the complexities of the ecosystems that don't look like, the Boston type ecosystems, but they look more like ours. Look, let's face it, the university structure in Greece, I would not use the word meritocracy generously for the university system. And Israel is not, they're just a little smarter than us, but they're not a whole lot better. Certainly have a better, economy than ours, but you see what they're going through right now, politically speaking. So they got issues. But look, the lessons are there. The question is there political willpower? Is there a buy-in from society at large to do the right things? And I don't know. That's not my expertise. I know the answers. I don't know how to implement them.
So one of these examples, though, people that emigrated, as you mentioned, that emigrated from the U.S. to Israel. We've got next to me sitting a person that just emigrated temporarily or permanently from the U.S. to start this ambitious project. So he's going to tell us more about the project that he's working on. So I want you to help Stelios design this and make sure that he's successful. What can we wish and advise Stelios to be successful? Because we're always saying, there are no initiatives. Αυτός ο Χριστιανός εδώ, I can't translate that. But he actually took the step, right? He actually took the step. He left his career in Silicon Valley, very successful career, and now is here. So Stelios, do you want to share what you're up to?
Sure. First of all, let me say I'm delighted to be here. Thank the organizers and you, Lambro, for being in this position to be close to Mr. Papadopoulos, who has been a leader and an example for us, the new generation, abroad. So it's true. I've spent over 30 years, I don't want to say exactly how many in the US, most of them in Silicon Valley, working in drug discovery, drug development, startup world. And recently, having met Eleni, she introduced me to a novel concept, a new idea that has been brewing apparently here over a period of many, many years. I don't even know exactly how many, 7, 8, 9 years. And the idea was basically very simple. Can we create something in Greece that will put us closer to what we call innovation in biotechnology? Now, this is a big task, a big objective, a big dream, I think. But at the same time, the whole idea is that we need to take some first steps forward in that direction. So the concept basically was the creation of this Athens Life Tech Park, as we call it, which is a modern space that will actually try to participate in this biotechnology arena. How is so? Initial idea, basically, we have split it in 3 or 4 different parts. One of which is services. We're trying to establish a typical preclinical CRO that will screen drugs and compounds, get them all the way through IND-enabling studies in time, not immediately, but we got to start from somewhere. An incubator system to help foster innovation and bring people closer. The few people that do drug discovery in Greece, there aren't many, absolutely, you're right, but help them be closer and get advice. Help them in terms of what do they need to look forward to, what do they need to target, how do they best prepare their idea and their venture, and how to compare and contrast with other ideas in the space. So they can be competitive ultimately, not in the national environment, but in the international stage. And of course, ultimately, we hope to develop a translational medicines unit, as we call it, which is basically, let me call it loosely, foster innovation. But which way? We definitely don't want to become professors ourselves and do academic research. That's out of the question. Our idea is very simple. To find the right ideas worldwide and collaborate with the innovators, whatever they might be, and form small projects that we can focus on, and hopefully through these, one day, ideally, have one molecule coming out of Greece. This is our vision, this is our dream, that's why we're doing this. So, having said this, that, and this short introduction to what we're trying to do, and you have amazing experience. You've been close to so many ecosystems, natural ecosystems, as you said, in Boston. There's MIT, there's Harvard. The ecosystem is almost halfway there. But you've also been through places where these pieces came together to actually form this innovation culture, this innovation mechanism. From your perspective, what are the things that you would feel that would be the main factors that will contribute to the success of an effort similar to what we've seen in the US, but a much smaller scale in Greece?
So look, you make good points. And the one point which is intriguing, which I didn't hear before for the Alpen Park, is this notion of creating a set of capabilities that you can collaborate with foreign-generated ideas and see if you can do something jointly. We should come back to that. It's an interesting idea. Let me give an example, and let me say this in Greek, if you don't mind. Ας υποθέσουμε ότι θέλετε να φτιάξετε ένα θερμοκήπιο για να βγάζετε πολύ ωραίες ντομάτες. Χτίζετε το πιο καλύτερο στέρεο για θερμοκήπιο, όλα είναι έτοιμα. Εκτός από ένα πράγμα, πρέπει από κάποιον να πάρετε από κάποιο φυτόριο τα βλασταράκια τα μικρά, τις καλής ποιότητας ντομάτες. Αν δεν υπάρχει αυτό το φυτόριο, όσο καλό το θερμοκήπιο και να είναι, δεν μπορεί να γίνει τίποτα.
Τα μόρια όμως πρέπει να είναι ελληνικά, δηλαδή δεν μπορώ να πάρω ένα μόριο από την Ελβετία.
Αυτό που λέει ο κύριος. But the point is, you focus in on innovation in the form of molecules. That's where innovation starts. Innovation is new biology. Mm-hmm. And if you see all the excitement in biotech, it's not about some new molecule for something, it's understanding the biology. And then, kind of like the rest is, more or less, I would say straightforward without trivializing. It's not straightforward. And very often you see companies just focusing on a molecule, raise a lot of money, do the preclinical studies, But I think if your argument is, I'll create the structure and I'm going to have a lot of people, it's almost like a multifaceted, CRO, CDMO, something that will attract if it's a guy at, University of Heidelberg or in Tübingen or in, the Imperial College, somebody with some good ideas and wants to try something. It's, there may be something there. Keeping in mind all along, there's a certain efficiency in the marketplace. All these academic guys who are very good, not always, but more often than not, these are the guys who are behind the biggest new biology and new drugs. They're extremely well known in the global venture community. Because it's their job, the venture capitalist job, to know these people and go convince them sometimes to start a company around the idea. All these big advances, siRNA, gene editing, gene therapy, ASOs, all that stuff is really new biology and new chemistry, not just a little molecule.
Interesting.
So that's what you got to keep in mind. You're competing, and I would even, I give you an idea. I won't charge you for it. The major venture capital firms in the US right now, all the big names, Flagship, Polaris, Third Rock, 5 AM, what they often do now is they have, like Flagship calls it venture labs. Yeah. Mm-hmm. They actually have their own labs where if they get an academic idea, by the way, a good portion of academic research is non-reproducible, either because the academic scientist was sloppy, or lazy, on occasion fraudulent, or they use wrong statistics. Okay, statistical analysis. So if they get a great idea, looks promising, before they go put $150 million in the Series A, they'll spend 2 years and $10 million doing some basic experiments to validate.
Reproduce.
Now for them, this is now production job. Yeah. So if that 10 million could be done with 5 million, they can do twice as many ideas. So go convince one of these people to become the venture labs opportunity.
So you spoke about biology earlier, and I wonder what your thoughts are on the recently the Chan Zuckerberg Biohub, the San Francisco, Chicago, and I think the new one is in New York.
I'm sorry, what Biohub?
Chan Zuckerberg.
Oh, yeah, okay, yeah, sure.
Where they issued an RFA on biohubs, and basically the message is, we want ideas for the next 10, 15 years, exclusively on fundamental systems biology. Yeah. They only have one therapeutic area where they said they're going to focus for now, and that's in Chicago, and it's inflammation. The rest is fundamental biology.
Yeah.
So is it something that you are...
I'm not involved with them. But yeah, I mean, look, once you make a whole lot of money, you can start having ideas, some of which are great, some of which are crazy. And, you know, I've got a couple of good friends who are advisors to Jan Zuckerberg. They're looking for things that they're so off the wall that the NIH wouldn't fund. And by the way, there's something important here. If I write a grant application for something which is not really supported by data, but it's not unreasonable, you could argue why logically it could make sense, but you don't have the data to support it. The NIH will not fund you.
Yeah.
So some of these people, I mean, some of the venture people, I mean, Flagship, which is a big venture capital firm, Flagship is the one for most of behind Moderna. You know, their premise is, as they describe it, we like to go fish when no one else is fishing. Now, I don't fish, so I don't know much about it, but I'm told, you know, people like to go fish near where there's some reason they see the seagulls coming down, they assume the seagulls come for the fish, so they should go fish there. Well, Flagship goes to fish someplace else. And most of the time they find nothing, as they should. Once in a while they find a big tuna. And that's how they got Moderna. Kind of like out of nowhere. It was an improbable, 10 years ago, it was an improbable decision to do mRNA. And by the way, they also got a little lucky because the initial idea about mRNA was different than what's been applied right now.
That's right.
And I won't bore you with the scientific details. But that's the beauty of innovative science. I mean, there are places to even take off-the-wall ideas, I want to call them crazy ideas, and get funded. You know, there's an aging company that's been funded largely by some, you know, wealthy, you know, data science people because they don't want to get old, you know, so they want to beat death.
Interesting.
I'm waiting for the drugs to come out so I can use them too.
There's a space where I came from, aging. The last 10 years I've been working on aging. And my last startup basically is working on the mTOR pathway. Which brings the next question, which is, from your perspective in terms of drug discovery, not the tools,
Right.
the machine learning and the AI and whatnot, what do you see as the next big opportunity in drug discovery?
It's always the same answer, new biology.
Biology.
New biology. You got to understand new biology. I'll give you an example that we all now know. Immuno-oncology was new biology. Let me explain this for the broader population here. Historically, we've been treating cancer by essentially poisoning the body with chemicals, known as chemotherapy, on the assumption that cells that divide faster than normal, and these are often the tumor cells, are more likely to get poisoned every time they divide than the normal cells. It works, and that's also why you get side effects, because it affects any cell that multiplies, and the faster they multiply, the more it gets affected, like hair loss, sores, you know, skin and hair grow faster than, say, pancreas. Okay, so that was the way we did many things. Then we came up with some other ideas, and about 20 years ago, the scientific work started pointing to a particular phenomenon, which was the following. The body had its own ways of fighting cancer, but the cancer cells got pretty smart and essentially would put a brake on the normal cells of the body as they were attacking the cancer. So what did they do? They created a drug, the industry. They created a drug that releases that brake. So now it allows the body to go attack the tumor through its own natural means. Again, that's the whole essence of immuno-oncology. And you've got some of the biggest drugs in the business. I imagine you know the names of Keytruda by Merck, Opdivo by Bristol Myers. These are the two biggest ones. And they made huge impact. You know, as I was discussing with Marcos before, 30 years ago, if you heard the word metastatic, malignant, melanoma, the 3 M's, you might as well go buy a plot in the cemetery. Within a year, you'd be dead. And now, they can do pretty well. Lots of people survive. And that's probably melanoma is the best example where immuno-oncology has worked. It's working in lung, in many places. You get, look, once a tumor is metastasized, there's not a whole lot you can do other than prolong life, but whereas life expectancy post metastatic diagnosis would be, say, 6 months for a tumor type, it could be 4 years now. Does it matter? Of course it does. It's not ideal. It's not the best it could be so far as we would like it, but it's an improvement.
Thank you. And I would presume the same is in the CNS space, like Alzheimer's, Parkinson's?
Whew, that's an interesting question. There, the question of new biology is even more important. Let me define this a little better. The great success we've had in the last 30 years with cancer was understanding the genetic basis for cancers. The bulk of cancers are formed when some gene goes wrong, and on occasion if you have, for instance, the BRCA1, BRCA2 gene, which are implicated in breast cancer, these are inherited. Most of the other genetic malfunctions, so-called genetic lesions, happen randomly, stochastically, as cells divide and they make mistakes. Now, the body has correcting mechanisms. It can either correct the error in duplication or it can kill the cells, but not always. And once a clone of these cells starts taking over, growing uncontrollably, you end up with a tumor, metastasizes, and you die. The greatness of the genetic base of cancer spoiled us, and we started looking for the genetic basis everywhere. So many of us in the business, 10 years ago, would often say, okay, I will only pursue diseases where I've got the genetic basis of the mechanism of action because it's less risky. True. The problem is, in the brain, in CNS disorders, it doesn't appear as if you have singular genetic lesions that dominate a disease. I'll give you a good example. Amyotrophic lateral sclerosis. It's a devastating disease. ALS, you die in your 30s or 40s at most, and you get paralyzed on the way. In 10% of the patients, there's maybe a dozen different genetic problems we've identified that you could think if you could go do something about it, then you can improve the condition. The 90%, we have no idea what causes it. It's the sporadic version of the disease. Just a couple of months ago, Biogen actually came to the market with the first mechanistically based drug. One of these mutations, which accounts to maybe 300 or 400 patients in the US in all. This is all there is. 300 or 400 patients, not 1,000. We know them by name. They're all in the clinical trial. There's a protein called SOD1, superoxide dismutase 1, that seems to be overexpressed, overproduced. So we introduced a drug that interferes with the production of that protein, and lo and behold, it seems to be making a difference. Now, it was not easy. It was not something anybody else would have done. It took a lot of guts to do this and spend hundreds of millions in this program, particularly when you'll never make the money. Now, why do we do this? Are we bad business people? No. And Dora was there. Did you ever work on tofersen? So Dora is a former Biogen colleague. We did it in part because we felt we understood the mechanism of action and we thought it would work. And we feel a certain moral obligation to a patient community when we're onto something. We don't want to just deprive them because there's no commercial opportunity. But we also thought we can learn a lot about the disease, then maybe take lessons from that project to other genetic lesions, and then maybe understand more the market and maybe come up with something. And we have other projects, by the way, for the sporadic familiar cases that didn't work out. So these are a set of complex decisions. But CNS is tough. Like right now, we have no idea why people get Alzheimer's. We, in fact, are not even sure if that famous amyloid plaque is the reason. It seems that most patients with Alzheimer's, defined diagnostically, seem to have a lot of plaque. But then on autopsy, you open some brain, it's full of plaque, and the person died at 95 solving crossword puzzles. Or somebody dies at 75 with severe Alzheimer's, they open the brain, there's no plaque. Now there's another protein called tau, taf. That's also implicated. Okay, which one is more important? We don't know. So we're trying all sorts of combinations. But that's the biology is what matters. It's not about the genetics. So it's tough.
Thank you.
Interesting. Very encouraging.
Listen, whatever you do, don't get Alzheimer's. No, but if you do, assuming this drug gets approved today, let me see if it get. I should be getting an email as we're speaking.
Well, they got the tau test by Ross yesterday. The blood test.
For tau?
Yeah.
Brain?
Why?
Tau 217. Blood test.
Why?
For early diagnostics.
Boy, they're over promoting this thing.
Yeah. Well, I work for organizations sponsoring that, so I want to promote it. So, all right. So speaking of organizations that promote this, and I'm going to switch topics a little bit, going a bit away from the actual molecules, and going to the support, the financial support for all these projects. And we've seen transformation in the financial sector. Where do you think things are going? And I want to, my 401k, for example. Yeah. Okay. Speaking of which, my 401k is, I thought I would do my S&P placement and I would be happy for 5%. Now, my bank is giving me 5%. So why should an investor now go in and invest in a startup? And we see LPs, retracting from venture capitalists. We see the overall venture capital funding being shrunk.
Sure.
Venture capitalists hold on to their existing placements. They don't do new stuff. Do you see this model of innovation, fostering innovation through venture capital funding mainly, being preserved, or do you think this is going to change and be supported by grants or strategics outsourcing their research? Where do you think things are going?
No, I mean, all these things do exist already. I mean, it's not venture capital alone supporting new companies. Big pharma companies make deals with them all the time. Sometimes they even get a government research grant. They outsource part of their own work. But fundamentally, I've been watching this space for 40 years. The proportions may change based on market conditions. The absolute numbers may change based on market conditions and a ton of opportunity. But the mix of the available sources of capital and how you go about it is the same. And there's a certain sensibility to this. The reason why venture capital is shrinking now is pretty simple. For the last several years until 2021, until a year and a half ago, every stupid company that was funded by venture capital could do an initial public offering, some big number, and they booked it as a gain. They distributed the stock. Everybody made money, smart and dumb together, and they kept on bringing more money to put back in there. Now the IPOs have stopped. I mean, this year so far, we're in July. There've been in the US maybe 5 IPOs or 6, as opposed to all of 2021, there were 110. We're doing 16 a week. Yeah. Okay, so, but that's nothing new. Okay. I mean, if you just look at any chart of financings over the years, you'll see the ebb and flow continuously. The strategics are always there, based on the difference with strategics is, for them, look, a lot of people think, here's an erroneous thought. A lot of people think that a real smart executive can sell effectively a biotech company to pharma. Not the case. You cannot go to a pharma executive, a CEO or CFO, a head of BD, and say, here's why you should buy this company. For them, for them to get to the point of deciding to buy a company is usually after a year or two of strategic analysis, planning, deliberation, due diligence, domain analysis, and then they say, okay, these are the two companies we want. Then they go, and if you're clever, negotiate on behalf of the small company, you can get them to pay you a lot of money because they want it now. So biotech companies are bought, they're not sold. And if anybody claims they're very good at selling those companies, either they don't understand the process or they're lying.
So how did you do it? You sold your company. So how did you build your company to be attractive to an acquirer?
So, I mean, much of my career was an investment banker, so I was transacting on behalf of people. So what I did is, as an investment banker, you realize that you essentially have three assets: your wits, your reputation, and your time. Okay? You're as smart as you are, your reputation is what it is, so you cannot futz with those things. Your time is the only variable you can change. Now, time is important because you get involved in a transaction, and if it doesn't come to fruition after a year, you wasted a year of work and you get no fee because you get paid on success. So I pretty quickly developed a tendency to do what we call, sell-side assignments. Identify a company, figure out they wanted to sell. I didn't hear what they thought they should get and all of that because either they don't know what they're talking about or they're lying to themselves. They think they're going to negotiate with me. And I would just go do it, and 90% of the time, there was a deal done that made them happy, believe it or not, and I got paid a fee. So what was that? I mean, you have to have some assessment of what people want. And it's not like I convinced the pharma company to buy something they didn't want to buy. Is that happened to be, like I said, I describe M&A in consumer terms. There's some people that go to the store to buy stuff to engage in transaction so they can change money. And then they go, the next day they bring it back. They exchange and they get their money back. Others buy on sale. If there's something that's on sale, whether they need it or not, because they're just, infected with this opportunity. And that is my wife. And my wife doesn't go shopping, except she has to go shopping for her daughter's wedding. And she has one day to go shopping. If she finds the black dress that make her look skinny, she's going to buy that dress, whether it's $1,000 or $5,000, it doesn't matter. But it's not like the department store convinced her. Right. She wanted, she was a willing buyer, and he just happened to show it. Okay, great, that's the one. Right. So that's the mindset. That's how companies get sold.
So that's from the startup perspective, but you've been on the other side now. You sit on the board of a big company that buys companies.
Yeah, right. How do we buy stuff?
Yeah.
We don't. I've been accused of not buying stuff. The reason? Because, so there are two ways to buy stuff. You can buy stuff that's too early, okay, and nobody gets excited because if you have a company with a $15 billion business and you're going to bring in something that might get you $1 billion or $2 billion 8 years from now, who cares? Yeah. The investment community does not care. So what everybody wants is something that's going to give you $2-3 billion on top of 15 next year. Well, by the time they're that big, they're well known. And what's more, everybody wants one of those. So they're priced beyond reasonableness. So one more thing that's a little technical. When you announce a transaction, a merger, an acquisition, you look at it from a couple of different points of view. One is, if I have to spend $10 billion to buy this company, how will this affect my earnings? Will my earnings go up or will they not? It's called accretion dilution analysis. The other question is, will this represent an above average risk-adjusted return on invested capital? Now, if you run any kind of a business, if you got a grocery store and you want to run that business, ideally you like to go buy from a milk producer a carton of milk for $1 and then sell it for $1.20 so you can make some profit, okay? And then you say, I've made money. I invested $1 and I make $1.20. And that's the way it is. The problem with Wall Street is that they are somewhat naive in the sense that they don't focus too much on return on invested capital, because, by the way, that would be like a 10, 20-year calculation just to see what happens. So there's a reason for that. The accretion analysis is very easy. Let me tell you what happens, particularly in an environment where interest rates have been for a while 0. So I got 10 million in the bank. It's giving me 0 to contribute to my earnings. I take this 10 billion and I overpay for a company that's going to give me an extra $1 on top of $20 of earnings. It's accretive. So why should I not do it? Well, you shouldn't do it because you've overpaid for this and your return on capital. You will never make the money back, but your earnings will be accretive. So that's some of the technical aspects of how people look at deals, and that's why I didn't want to do them. I'm sure Biogen, now that I'm gone, will do stupid deals. Don't tell them.
So if you assume that you were into doing some deals, what would
I
you
would have
be-
done deals, don't get me wrong, but you know.
No, I'm sure. I'm trying to understand basically what would you look for? What would you want to see in somebody to be attractive enough?
Yeah,
Because you
yeah.
said you want to buy them, not them to sell
So
to you.
at what size are we talking about?
Let's say total acquisition size between 300 and 700 million.
And let's define the company stage. Is it preclinical? Is it clinical?
Phase
is it
one.
concept?
Phase one, phase 2A.
Yeah, I mean, typically the way this, let's say take a Biogen. Our Biogen's market value is say 40 billion, 50 billion, somewhere there, okay? They're looking at a company that's going to cost them 500 million to buy. They can write a check for this. It's not easy. So why would they buy it? 100% for strategic reasons. This company has a phase 1 compound which is very compatible with what we do. That's important. More often than not, something people don't really appreciate. Let's say we have a lead scientist in the company who has a very good relationship and spend time working with the lead scientist in the small company. Has a lot of respect for them. He will vouch and say, look, the work they're doing is very good. Here's what they're finding. Their particular approach makes sense. I trust this guy, I respect this guy. Let's do it. Fine, sure, we'll take a chance if it's strategic. But not simply to add revenues.
Right.
Because it's very hard. It costs a lot of money to sell drugs. So Biogen has sort of like a sales presence in the neurology space. We couldn't sell a cancer drug, even if it was a gift from God.
Right.
We don't know any oncologists. We have to go assemble a team, train them, indoctrinate them, and get them in. We don't even know who the good guys are. So it would have to be very much along. So if somebody came to me now with a sporadic ALS drug in phase 1, I would snap it up right away, assuming it was good science. It's very strategic. If it was a novel idea in multiple sclerosis, they seem to make biological sense, all over it. And we look at all these things all the time.
So
We
the
used
alignment
to.
with your strategy, the alignment with your strategy in terms of where you want to ski.
Every big pharma company
Right.
does it this way. Sometimes the strategy is, well, we now want to add. See, Pfizer was not a huge cancer company, but years ago they started buying up cancer assets. So they want to expand their cancer presence. So now they keep on buying and buying. They become a major cancer company.
How often do you change strategies in big companies? Because
Unfortunately, too often.
yeah.
Because typically, when companies don't perform, CEOs will revert to reorganization and new strategy, or do a stupid acquisition, as we said, to kick the can down the road and delay the decision of their. I mean, look, Bristol Myers. They were running out of time and space. They bought Celgene. They bought themselves time because Celgene had a, money-making drug that's just going generic now, and a couple of other drugs. But so Bristol Myers now, 5 years later, is in the same spot. So they're going to reorganize. They already lost their CEO. If a 58-year-old CEO announces retirement to spend more time with the family. And you know, neither his wife nor his kids are sick. He got fired.
Yeah.
That's what happens. 58, you don't go
Yeah.
to spend more time with your wife. I mean, even if it's a good wife. The secret of my success in marriage, I've been married 44 years, is until COVID, we never saw each other. Now with COVID, it's getting tough. Right, Simo? You spend way too much time with your wife.
So speaking of
Wives.
families, well, families in general, your personal journey, and just to lighten up the discussion a little bit. So I hear that very often from academics especially, saying, oh, you know what, I'm not tailored for business. I'm an academic. I don't have the skill set. I can't go there. So they're scared of business. And then I know investors that say, I'm scared of academics that are scared of business. But you made the leap. You went from the wet lab, you went to investment banking from all these
Right,
things. So
right.
how did you make this? And this is more on the personal level, but how did you make that decision to go there?
Yeah, I was programmed to do that. The world doesn't know this. Now, Marcos knows it. Once he broadcast that podcast, whatever it's called, everybody will know. What people don't know is two things. I did grow up as a good kid, good student. I was very good in school. Okay. But from the age of 9, in the summers, and then later on from 15 onward, every day in the afternoon, I worked in my father's store. So I can say this in Greek. Ο πατέρας μου είχε ποια είναι Θεσσαλονίκη εδώ. Okay. Είχα μαγαζί στα Λαδάδικα, με μπαχαρικά. Και πήγαινα και βοηθούσα, πήγαν στις τράπεζες, μάλλον με τους χαμάλιδες, φώνηζα στον δρόμο, μιλούσα με τους πελάτες και μ' άρεσε αυτή η δουλειά. Μ' άρεσε. Φυσικά ο πατέρας μου φουγαράς ήθελε να σπουδάσω για να έχω μια εύκολη δουλειά και όχι να είμαι στα μπαχαρικά. Τέλος πάντων. Και μετά στην Αμερική, όπως όλοι που πάμε, ιδιαίτερα τον καιρό που πήγα εγώ, δεν υπήρχε καμιά οικογένεια από την Ελλάδα που μπορούσε να υποστηρίξει οικονομικά ένα παιδί στην Αμερική. Και πολλοί λέει πηγαίναν. Και τι κάναμε? Δουλεύαμε. Πού δουλεύαμε? Κυρίως σε εστιατόρια. Κάποια στιγμή έκανα ένα LBO με τους φίλους μου και αγοράσαμε ταξί και ποινικιάζαμε ταξί. Πουλούσαμε παγωτό στο Central Park. Η δουλειά είναι. Όλες αυτές τις δύο πράγμα είναι. Είναι η επαφή με τον πελάτη, με αυτό που σου δίνει το προϊόν, οι καυγάδες, το ρίσκο. Δεν είναι τίποτα διαφορετικό με το investment banking. It's all the same thing. So I was ready for it. There was no doubt. But I love science. That's my problem.
Yeah, that's a good problem.
So it's a problem because I know you may say, oh, no, but I never become as good a scientist as I could have become or as good a business person as I could have become because I served two different masters. That's all right.
Interesting. So another question that I had is right now, beyond all your board seats and all your executive roles, are you working on something new and on something new that you can share with us, or a non-profit or a startup, or is this?
No,
or
I mean, more the same. I mean, it's the not-for-profit. Many of you know this, but many of you know Spiros Artavanis. He and I, in the year 2000, started a foundation
Tell us about it.
called Fondation Santé. And what we wanted to do was offer financial support and mentorship to academic scientists doing research in biology in Greece. Not necessarily Greeks, but in Greece. Not Greeks outside of Greece, in Greece and Cyprus, to be fair. Because we thought bringing in a more serious way of doing research would be of value. Now, what we've done in this 20 years plus that we've been doing this, and we give about €500,000 to €1 million a year, largely from donation of ourselves, other Greeks, and Phil-Hellenes were part of our broader biomedical universe. What we've done, which is a novelty in Greece, is number one, every September, year in and year out, there's an announcement of requests for proposals for grants. Regularity in Greece is a luxury. People have come to appreciate this. The next point, which is even more important, their grant applications get reviewed by a scientific advisory board. Only Spiros, of course, is Greek. All the others are exceptional scientists, all friends of Spiros, including several Nobel laureates. So, if you are a young scientist at University of Patras or Ioannina or whatever, and you know that David Baltimore got a Nobel Prize in biology, reviewed your application, you feel pretty good. And the other point is there's a conviction, absolute conviction, that the grants are given on the basis of objective judgment and not, well, I know the guy who is the driver for the cousin of the sister of the cleaning lady of the minister's office. I'll put a word, we'll get there. So these things are important. Have we made a difference? I think so, to some extent. We've made enough of a difference in that these people do a little bit better work. They've developed a sense of community. We gather them every year to present their work to each other and to us. They form collaborations. But the real missing link here, which calls for a lot of money, and we have the expertise to do this, is a huge endowment to attract leading Greek scientists and others, not just Greeks, from abroad to come here. So if you could, and we're working on this, we have some ideas. If you could offer somebody, $1 million startup grant to come back and set up shop at the University of Athens. If he's like a super duper guy, the Price postdoc of George Church's lab or David Liu's lab, these are some of the big names out there, you may go to Harvard. But between Harvard and a tiny college somewhere, there's a big distance, and a lot of the distance is well above the level we have here.
Yeah.
And it's not only the quality of the science, but it's the mindset. What it's like to do good science, what it's like to work hard, what it's like to collaborate. And we need to get that sensibility into the academic ranks.
Interesting. We do have academics here, so this is good that you're sharing this. And thanks. Are there particular therapeutic areas that you're working on?
Basic science, it's mostly molecular. At the basic science level, it's not a therapeutic area. It's really molecular biology, biochemistry, cell biology.
Interesting.
So what else you got from me?
Well, we've got a nice question. I don't know, Stelia, if you have anything in your notes that we didn't cover. And I know we skipped a few things that we planned.
We did skip a few things, but I think we covered for the most part.
We are, okay. So we do have some questions that we collected from the audience.
Okay.
And one had to do, and again, I know you're mainly a drug person, so unfortunately, most of our questions are not in drugs, but let's see if we can tangibly connect with them. Diagnostics, I see here a question. Where do you think personalized diagnostics is going? How does this fit the pharma ecosystem? Early detection of a disease, for example, and what is the recommended process, for example, to take a diagnostic? Let's say that I have a new tau 217 blood marker. How do I go about it and sell it in the US? Do I go to a pharma company? Do I go to an insurer? Do I go to Medicare? What do I do with it? How do I start?
You got to go first to the regulatory authority to get approval.
Besides that.
Then you have to go to the diagnostics company. A drug company will not sell a diagnostic.
Okay.
So you have to go to whoever is the right diagnostic company. Roche, being a good example, or many smaller ones. The problem with diagnostics, and you touched on the word of personalized and early detection, there are things we can talk about. The problem with diagnostics is there's never been proper pricing of diagnostics in the US. Okay, now, for instance, let's assume you have a simple case. Let's say you have, I wouldn't call this a diagnostic as such, but it's a prognostic of reaction to a drug. Let's say you have 100 patients who just had a mastectomy and they're candidates for adjuvant therapy with some chemo, whatever. There are tests now that can tell you with a high degree of certainty whether the patient, based on the genetics of the tumor, will be benefited from this drug. So let's make some numbers. Let's review 100 patients. Let's say that a year's worth of treatments, let's say on average, they'll be treated for another year with this chemotherapy. Some in 6 months, some a year and a half. And let's say the cost of the drug is $200,000 for the 1 year per patient. Okay? That's what the insurance company or the government will have to pay. And let's say that you could exclude 30%, or make it 33%, so I can do the easier math, of the patients from this. So you're saving now 33% of 200.
Because you rationalize where you're giving the drug to.
Right.
Yeah.
So if that's in an efficient setting, I should charge $66,000 per patient per the test to break even.
Yeah.
So I give them a little opportunity, charge 50. They charge 5.
Yeah.
That's the problem.
Yeah.
So I would never want to get into the diagnostics business because of that. Now, you brought up another word, personalized care. That's a double-edged sword. Personalized care is very good if it's able to give you a benefit that otherwise you wouldn't get, because the testing tells you precisely what you have, so they give you a targeted drug for it. The problem is no drug anymore is a big drug. Part of what makes drugs a good business is you give them to everybody, and you hope it works on 30% of them. I mean, most drugs you give for cancer work well for 10, 20, 30% of the patients, but everybody gets them. If you start targeting, then the business shrinks, but the regulatory expenses are the same.
But if you target, if you do infliximab versus, if you do Stelara versus, some other, anti-inflammatory, wouldn't you want to know what works on that patient? A third of the patients won't work, so.
I'd be very curious. I'd like to know, but somebody who's selling drugs, whose business to sell drugs, may not want to know. Why would they want to know?
Not very
Curiosity
romantic.
killed the cat.
Yeah. Interesting.
So diagnostics is, and everybody bemoans this. The same thing like antibiotics. We have a real problem with antibiotics.
Yeah.
The pricing is bad.
It is.
So, God forbid you're in a hospital and they give you vancomycin and then you develop vanco-resistance, disease. What do? Nothing. And there's stuff that can be done, but nobody would spend the research dollars if you're going to charge it like a generic. Makes no sense.
Yeah.
Because like I said, I'm not running a charity. You invest with your 401k, your money, into Fidelity, and Fidelity invests in me, and I got to make you rich. I want to, work on your retirement. I want you to be happy.
Yeah.
So I got to make money for you. So long as I don't break the law, I've got to do it. If I don't do it, they'll fire me. They'll put somebody else in my place who will do it. Yeah. The shareholders will rise up in arms.
Yeah.
So if I take the last thing
you want to take care of your retirement too?
Sure. If I take your last statement, would that mean that you value very highly the rare disease space? Where
I don't.
You don't.
And I'll tell you why. And that's a minority view. People have come to love the rare disease space because the regulatory path was easy. I give you some examples. The celebrated drug for rare diseases is one called Ceridase that was developed by Genzyme. That drug was approved, if I remember right, April 21, 1991, on the basis of a 12-person clinical trial with no controls. Okay? And then it became a $1 billion drug. Why? Because they were charging $200,000, $300,000, $400,000 per patient per year. So on from there, many drugs hit the market like this. In the beginning, the insurance companies were sort of like tolerant, and Genzyme was very good at this. They were tolerant of this in the sense that these patients who had the particular disease that required ceridase, it was an absence of an enzyme called glucocerebrosidase. They would have a lot of morbidity. They would have enlarged spleens, they need splenectomies, they have brittle bones, they go to the hospital all the time. So it turned out that their care was quite expensive. Mm-hmm. And the other point is there were not many. In all, at peak, maybe there were 5,000 patients in the US. But now if you add 1,000 diseases with 1,000 patients, it becomes a big market. Right. So the payers are beginning to ask questions and resisting. And some of the smarter drug companies are moving away from the rare space. And what they like to do now is have severe enough forms of reasonably abundant diseases they can charge $5,000 to $10,000 per year, as opposed to $500 to $1 million.
They're
So
going for 5,000 as a
I wouldn't want to start a rare disease company today.
So that target would be autoimmune, for example?
It depends which autoimmune. Autoimmune is multiple sclerosis. Yeah. That's a big market. Yeah. It's 200,000 patients in the US and then some. The rest of the world, you can probably amount to 1 million patients. I don't know, Dora, you know these numbers better. Is it globally about 1 million patients for MS?
About that.
Yeah.
Or higher, maybe.
Yeah. Now, of course, not every country can pay. I mean, I can tell you, going to China is an enormous problem because if we sell a drug for 200,000 in the US, 100,000 in Europe, in China we'll get 3,000. Now, volume makes up for it, but I'm worried as hell that at some point in the next year or 2 or 3, there'll be a congressional hearing after China does something funny, and some senator is going to ask the CEO of a drug company, Mr. So-and-so, you mean to tell me it's tough enough you charge double our own citizens who pay taxes and support the work than the Europeans who are freeloaders, don't even contribute to NATO in the right proportion. But the Chinese, our biggest enemy, 1/100th of what you charge our citizens? Why? There's no good answer for this. They say that's all we can get, because that's what it is. Once you've invested in R&D and you've spent 10, 20 years and $2-3 billion to develop a drug, at that point, if you get above your cost of goods and your cost of sales and marketing, it's profit. Right. So you'll do it if they play hardball. But it's going to be a real problem. Right. I wouldn't even want to go to China, period. Right. I mean, not to visit, but to do business.
I agree.
Or to visit, it's too far.
Another area of questions, and again, I know you mentioned you're not a device person, but let's, since, as we saw in the infographic, there's a lot of people here that do digital. And in a way, digital and drugs sometimes go together. You got disease management programs, you get metrics that come, you got patient engagement programs going through disease. And it's very important to take your drugs, right? If you don't take your drugs, then they don't do you any good. So where do you see this? And are there tangible results for Biogen, for example, if you're looking at a companion therapeutic, for Parkinson, for example, putting on sensors on your body and letting people know how to titrate your drug?
Sure. No, all these things make sense at a price.
Okay.
See, this is what people in the IT world need to do, is they need to understand how much business am I doing without them, how much more business will I do with them, how easy it is to implement, how regulatorily feasible it is to do, and what do they want in exchange. They got to come with it's a business proposition. It's increasing market share, either through longer adherence of a single patient or acquiring new patients who like that kind of capability. So it's got to be a very clear business proposition.
And you see that happening at Biogen.
Sure.
You see that. So, for example,
Yeah, we're looking at
you
everything.
run the intuition study, for example, and you're looking for early detection of Alzheimer's. How are you planning to monetize this one?
We will not monetize this ourselves. Okay, we will, enhance the market. I mean, it's like I said, ourselves. What I mean by that is the way we monetize is by selling more drug.
Or
We're
get
not
them
in-
to get your drug instead of somebody else?
Yeah, we sell more drug. Whether it's new patients or old patients, if we sell more, we make money. So I got to be convinced that this capability is going to generate greater revenue for me.
And are you convinced?
Not yet,
Okay,
not yet.
interesting.
Look, there's a lot of, what would be great is if you look at the way somebody gets diagnosed with Alzheimer's, you take a little test called CDR sum of boxes, which is kind of like idiotic and very sort of like unquantitative. Yes, did you forget your kids yesterday? Yeah, check out, you get a point. Did you forget your daughter's name or whatever? And the other is through a PET scan. Now, what the CDR sum of boxes tells you that you have some processing issues. And there are many other tests like that, don't get me wrong. What the PET scan tells you is you do or do not have amyloid in your brain. And that in itself, now if you have clearly a case of CDR sum of boxes that just Alzheimer's, if you have amyloid, you say, probably. And now, with aducanumab, donanemab, and lecanemab, the clinical trial data, it's becoming clear that patients who start with plaque, within a year or two, most of them have a lot less, if any, detectable plaque, and they seem to be doing, on average, better on those tests. So there's a stronger connection now with that. But it would be great if there was a real digital test based on data collected from 100,000 patients. You look at your iPhone and, I tell you, there's a game on computers, it's a very old game. It's called Memory Blocks. I don't play computer games, but this is interesting. It's basically a grid of, say, 6 by 6 yellow blocks. You flip one and shows you a design. Yeah. You flip another one, shows you a design. If it's the same, they disappear. So the question is, how fast can you, and how many and how few flips can you use to do that? So I can tell you this, I've done this quantitatively. I'm much better in the morning than I'm at night.
Of course.
Of course. No surprise there.
And after coffee or before coffee, for example?
I don't know about coffee. I drink so much of it. I'm like on background coffee all the time. But imagine something far more sophisticated than that with your iPhone, detecting the intonation of your language, making you do simple skills that everybody would do after we validated this with tens of thousands of patients. They will say, something is wrong here. And let's then separate what is a natural course of cognitive decline that comes with age from Alzheimer's, which is pathological.
But still, who would pay for it?
The NIH.
So you need
It's a social service because it's going to be, you can probably protect this with patents. But the government in the US, to their credit, have done the most famous big project for public health was the Framingham study, where they collected an abundance of data on cardiovascular disease with many, many people longitudinally. That's where all this stuff came out, the cholesterol implication and many other things. So it's not unprecedented for the US government to get involved.
Well, they expanded the Framingham brain health study, so they now have brain as well.
Yeah. Scanning imaging studies are too expensive. Yeah. Especially in the US, I'm amazed. You can go get, you guys tell me if I'm wrong. If I go to a hospital and get an MRI and I pay out of pocket, how much would they charge me? 100 euros?
Brain is 350 euros here.
Yeah. It's like 10,000 in the US. Yeah. By the time they add this and they add that. And Of course, nobody pays that. There's a complicated, convoluted settlement with the insurance company. So they pay something a lot less than $10,000, and you pay $50, and it's all forgotten, but you don't really know how much money changes hands. But because the thing is, if a hospital, for-profit hospital here, charges you 300 euros for an MRI, they buy the same machines. They're probably more expensive here than in the US. They got to operate them with similar amount of power consumption and personnel need. Why are they so cheap? The problem is US hospitals are overloaded with personnel, with procedures, with many things, and where they probably lose money is treating the very advanced patients who require a lot of care. And that's how they make it up. And by the way, hospital accounting is particularly dismal. Hospitals don't really know how much money they're making or losing.
Right.
Because most of them are not-for-profit organizations. It's nobody whose pocket gets lined or not lined. It's some amorphous, entity that no one feels ownership of.
So one day, my phone would say, check engine light, something is wrong with your brain.
Exactly.
And then
It'll
go
happen.
to the doctor and do your other tests, but it's just going to be checking us.
Yeah.
And then we're going to enter the treatment ecosystem earlier on.
Yes.
Than not,
In any disease, early treatment is better than late treatment. Now, the only thing doctors will tell you that's important, because there's a whole trend for like executive health. A lot of wealthy executives will go spend 3 days in a clinic and get full body MRIs and every lab test known to man, do all that stuff. Then they walk out and they feel good about it. What doctors will tell you is there's a whole things that you can discover that are inconsequential. And by the way, in my own personal case, I had a bad kidney stone 30 years ago. And in one of the imaging analysis at some point, they saw a huge lesion in my liver. Panic. Okay? So I went to liver, that. It turns out to be kind of like a strange thing. It's called familial nodular hyperplasia. It comes up at some point, grows, and it stops. And I probably still have it. After 10 years of MRIs to follow it, guy says, you're not dying, you're fine. So had I not done the kidney imaging, I wouldn't have seen it. And I've seen lots of things in my body. My wife is a doctor and she accuses me of being over-analytical. She says, yeah, you're fine. When you're sick, you'll know it.
Well, not to discourage people to take their tests, right?
I would think twice about doing these totally comprehensive things.
Yeah.
Because many times you get into this blind attitude. You see something which is, look, if all of a sudden you saw a tumor, great. But more often than not, you will see something somewhat inconclusive. And you keep on doing more tests and more tests. And look, at some point, the healthcare system will collapse. Yeah. We're testing all the time.
What happened to me was something that we didn't know, and it was a tumor. So it was lucky that I found it, though. So,
right, so that's why you're alive.
Yeah.
Okay.
That is part of the reason why in certain Alzheimer's, some of the insurance companies like Kaiser, I used to be at Kaiser, the way they test you for Alzheimer's is the MMSE test.
MMSE test.
If dementia, therefore you're an Alzheimer's patient. You pass the test, you're good, you're fine, go home. So none of these complicated tests that are pretty complicated because simply you cannot tell the difference between the normal aging pattern versus the disease in early stages.
The other thing is that there were no real drugs to give.
Right.
There were a couple of, as they call it, cholinesterase inhibitors. They were not doing much of anything, so why bother?
Yeah.
And it's not always Alzheimer's. It could be AFTD, it could be Lewy body,
Could be a number of things.
Parkinson's, it could be anything.
A number of things.
Right, we're past our time, and I wanted to see if there are any questions, if you don't mind taking, maybe a few questions.
I'll suffer. You decide.
All right, okay. Go ahead, sir.
No, she got the microphone.
She got the microphone, okay.
She knows the guy with the microphone.
Thanks a lot. Fascinating and very inspiring exchange so far. So my name is Mata. I'm from Thessaloniki. happen to work at UCB, a biotech pharma medium-sized company. I'm curious to learn a little bit more from your personal journey. What's your personal biggest bet you've taken so far? So if we kind of focus a little bit on your biogen journey, a key decision you have made, personal bet you have taken that may have read out or not, what would you choose? What would you
By
pick?
far and away, the biggest bet I took was in 1980 when I decided to go to Wall Street, and I essentially put my academic career in the background and focus on going to business school at night. If it hadn't worked, if I hadn't gotten a job on Wall Street, I would have been out of academia.
And that was a turn,
Well, this
massive
was-
turn for you. Yeah.
I'm not sure I fully appreciated the risk involved in the decision at the time, but that was by far the riskiest thing I've ever done. Most of the other things, I create optionality around what I do, and if one thing doesn't work, there's something else.
You did pretty good from where I'm standing.
It could have been different.
And within the pharma industry?
Do
Within your pharma
within my pharma
journey?
career,
Yes.
probably the toughest thing that worked was continuing to fund Spinraza. That's a miraculous drug for a disease called spinal muscular atrophy. And I was instrumental in convincing the rest of the board we should bring it in. So was the CEO of R&D at the time. And then after a year or two, there were huge overruns in clinical trials. We made a very tough decision to do a controlled trial with placebo arm. And these were kids. If they were not treated by year 2, they died. So we actually killed some kids knowingly to get compelling evidence that the drug works. It was a tough one.
And it worked.
Yeah.
Well, you're talking about the control arm, right?
Yeah.
But, yeah.
What company was that?
Biogen. The drug is good. It's this, what's the name of this member of parliament on the wheelchair? Πώς το λένε? Kibouropoulos, yeah. He's got that disease, but he's got type 2, type 3. Type 1 is the one that you die within 2 years. There's a microphone there. So,
Sorry, Rini. I'm Dimitris Trifon from Melbourne. Thank you for the very insightful speech. So we know there is a situation in Russia, of course, and we know that in Russia and Ukraine there are a lot of clinical trial sites from the big pharma. And I know that Biogen also has, I think, 2 studies there.
where?
In Russia.
In Russia. Oh, yeah.
So is this a problem that the data that was created there, is it in good hands? Is it lost?
Yeah.
Is it delayed?
All clinical trials in Russia and Ukraine have been delayed. By the way, this is not so much our choice. Nowadays, clinical trials are carried out by dedicated companies that do clinical trials. The biggest one is IQVIA. So why do they go in Eastern Europe? Because they go a lot for 2 reasons. One, you may find naive patients. Naive is a term of art. Naive is a patient who has not been treated with similar drugs for the same condition. And in the beginning, you really want to make sure you give the drug to people who don't have any compounding contribution from another drug. And the second is because it's cheap compared to the US. So Poland, Romania, Ukraine was a big destination. The data are respected. And we had issues with Chinese data. The FDA had issues with Chinese data.
During COVID?
In general. In general. Not for COVID, for cancer and other things.
So it's not a big issue, though.
They delayed and then they activated other sites, you know, so. But it's a problem.
Let's take one more question back there from Leonidas.
Thank you for the very interesting discussion. My name is Leonidas Alexopoulos. I'm a professor at the National Technical University of Athens.
We met
Yeah, we
at
have
the
met,
MIT
before.
meeting.
He's a genius.
Yeah, I was before for 10 years in the US. And I grew up, after the US, I grew up in the Greek academic ecosystem. You said that you are believing that basic biology is the way to move forward, and that's going to bring a lot of innovation, and there is no doubt about it that novel biology is going to bring you Nobels, new drugs, and so on. This might be a great opportunity for Boston, and that's how Boston works and finds the novel drugs, and then the people become professors at MIT, Harvard, and so on. But in Greece, this has a very high chance of failure. You're going to give a lot of, let's say, 5 million, 10 million, $1 million to many professors, and there's going to be 99% failure rate. So for Greece, that the ecosystem is not so mature like it is in Boston, I would argue that it's much easier to have the low-hanging fruits, even though it's not going to be the great idea, it's not going to make a lot of money, but it's going to make the ecosystem more mature. It's going to make the system to work. It's going to make the patents to become patents. I mean, to be able the university to have patents. So I would argue, like if we had in Greece a new CRISPR innovation, then you would not be able to have a patent, to have a Nature paper, and to be able to do the PR to move it forward. What do you think about that? Because you are supporting like the ecosystem as a tech with Artavanis and so on. You would think you are a strong believer of the basic biology, and there is no doubt that it's going to make things great. But in Greece, maybe it's not. I feel that it might not be the right place.
The only point I would make is we need to define. I agree with everything you say. I don't disagree. We need to define low-hanging fruits. In drugs, there are no low-hanging fruits. The only cancer drug that is good is the one that's better than all the rest. You can't have an okay drug, even if it's a lot less price. So you have to go for maximum efficacy, safety combination. Now, I will paraphrase a bit and say maybe low-hanging fruit we mean other activities within the broader biopharma space that one can do here. And I mean, again, as Mr. Kontosamaitis will tell you, that's what we proposed. There's a lot of things to be done from Greece, in Greece, starting with manufacturing, enhancing our clinical trial footprint, providing pharma services to big companies. There's enough, the whole paradigm of software. What does this tell you? It tells you that Greece has enough, sophisticated enough professionals to do sophisticated enough jobs, at a much lower cost. So why not? All this can be done. Now, has there been any, and by the way, the lesson is that in the software world, we're beginning to see some now globally competitive companies, not just cheap labor adjusted for quality. Now, can this happen here? It'll take time. It will take a long time and a lot of money. 5 or 10 million is not for drugs. Because it's got to be prohibitively expensive. Companies nowadays spend $300 or $400 million as private companies, then they shut down in the US.
Can I start without the microphone?
Go ahead.
Even without the microphone. Okay, I wrote it down, sorry.
Are you from Thessaloniki also?
No.
Oh, I don't know that.
Lives in Thessaloniki.
Oh, there you go, okay.
Yeah. And I was there 2 months ago. So I'm a molecular biologist, but I'm also a businesswoman the last 10 years. But I really sympathize with you when you said that, between being a scientist and a business person, there's always this conflict. So what I wanted to ask is, with all this innovation in AI and data and whole exome sequencing and genomics, etc., I feel, especially after COVID, that we gradually pay more attention and invest more in creating drugs and machines to actually treat a disease instead of, at least equally spend money and innovation in preventing a disease if it is preventable. And because the money is actually in treating and not in preventing,
Right.
and I really would like your comment on that. And speaking of prevention, do you believe that by combining genomics, AI, biotech, we will be able in the near future to actually prevent the onset of a disease with a drug like the BRCA genes that you mentioned before? So instead of actually having cancer because of it, probably having a drug. And the last part is speaking of inflammation and Zuckerberg, etc., because inflammation is the source of many diseases actually. So preventing inflammation is a huge thing for better health. Where does the microbiome stand in therapeutics and drug formation in all this?
Okay. Woo! Okay.
That's a new meeting.
So, so let's do them one thing at a time. So let me give you an example. There's reasonably good consensus amongst many of us that the Alzheimer's plaque that accumulates is probably the result of 20 and 30 years of low-level inflammation that causes that. Okay, now, suppose I want to prove this. I need to do a 30-year clinical trial. Who's going to do that? I would not allow any company I'm part of to do that when, in fact, after I do it and I show it, I got a drug, but then I also have drugs. So anything which got to do with health policy has to be driven by government or the World Health Organization or somebody, because this is almost pre-commercial activities. So do they have the guts to do it once in a while? Look, a pre-commercial activity with initiative from many places was smoking. You know, the campaign against smoking. That slowly, even in Greece, you don't smoke. Nobody's smoking here. If we were here 30 years ago, everybody, you know, for a while, the pilots of Olympic, even though there's a non-smoking, if you were sitting up front, you could smell the cigarettes. So I told the flight attendant, says, okay, θέλεις το παιδί να πάει ατσίγαρο στη Νέα Υόρκη και να κάνει κανένα λάθος, άστο να. So that's that. On the microbiome, I'd say I'm more disappointed, and I got involved in the microbiome company. I was a proponent early on. It turns out the microbiome is implicated in many diseases, but it's not at a clinically significant level. There may be some very few people. There's sort of like the gut-brain axis. A lot of people argue that your Alzheimer's is touching your gut or whatever. There may be something to it, but we just don't know enough. And I don't see, if anything, microbiome initiatives are on the decline than on the rise. And what else did you ask me?
I forgot.
Look at your phone. Okay.
Hi, everyone. I'm Irini Slosher, CEO and founder of Giannia Health. I had a specific question following up on the point with the randomized control arm that you did with the rare pediatric study. So I know recently the EMA and the FDA have both been quite open and accepting towards synthetic retrospective external control arms, particularly where there's a rare disease, significant unmet need, or pediatric condition.
Yes.
But prior to the recent omnibus bill, you know, and just for context, we work on natural language processing for extracting retrospective data sets from EMRs. But we've seen studies that were done on large B-cell lymphoma and others with manual chart review. So what led to the decision to do an RCT on such a rare disease with an ineffective current drug on a pediatric?
There was nothing, there was in fact nothing. It was the FDA. It was a brand new mechanism of action, and that's really the big puzzle. So what the problem was, these kids have a problem in their gene and the way it was being transcribed. So we gave them an antisense oligonucleotide that did what is known as exon skipping. It basically stitched over two parts and skipped one and read the rest to create, you know, a normal version of the protein. That was never been done before. So my guess is they probably had doubts it would work, and they didn't want to take that chance, and it was not a very long trial. But my guess is there's a lot more sophistication now with synthetic control arms. And, you know, for a while under Scott Gottlieb, when he was FDA commissioner, the principal deputy commissioner was Amy Abernathy, who had come out of Duke, and she was a huge proponent of all this digital way of doing trials. I'm not sure right now what's going on in that front. But yes, this is a big change. And I can tell you, ultimately, that's what's going to happen. I don't want to call it unethical, but if you can avoid it, You know, how can I, for instance, let's say there's a drug out there for Alzheimer's. How can I go tell somebody to get into a randomized trial, knowing that maybe half or a third of the patients will get a placebo? And this is not like, okay, after the trial we'll cross over and we give you the drug and you'll be fine. You've lost a year or two, which you never can regain. I can. That's what FDA wants us to do.
I think it's also timing, because now with the omnibus bill, I don't know when you were running the study, but that's why I was curious, because now they've been very proactive about.
We're not going to do
saying-
the randomized trial on aducanumab. We, again, I'm no longer there.
Interesting.
We'll take one more question, and then we can continue the discussion outside, because.
Well, the sidewalk?
Okay, that's one last one. Because
Short one.
Kostas is signaling back there.
All right, so I'll just make it very quick. Thank you so much for all the insights. My name is Spiros Kingios. I'm also representing the Greek pharma industry. Got straight to the chase. You mentioned immuno-oncology as a field where we saw disruptive new biology and you were in love with. You told us where you would like to see new biology, your targets. But what about, you know, what's actually happening now? Are there any fields where you can detect, you're now detecting paradigm shift in biology? You see something moving, you see something that's, you know, breakthrough, maybe not ideal for investment, not making a lot of business sense, but something like really, you know, keeps you up at night and you go and your scientific brain kind of goes zoom.
Look, I would say this. The space of neurological diseases, if you look at the number of small neurology companies 20 years ago, well, today is like night and day. There was not a single tiny neurology company. And 2 or 3 or 4 that started back in the 80s, Regeneron being one, Cephalon being another, Athena Neurosciences being another. Regeneron became many other things, no longer neuroscience, because the founder, Lenny Schleifer, along with George Yancopoulos, he was a neuroscientist at Cornell. And they wanted to do brain-derived growth factor and, you know, and all sorts of other things. Cephalon was another neuroscientist, and they tried insulin-like growth factor in neurological diseases. They became a cancer company. So through the 90s, nobody was starting a company in neurology. Now they're all excited because they see a lot of new biology and because they see on occasion even genetic linkages for subsets of the disease. So I think there's going to be action there. So thank you.
Thank you so much.
Thank you.
There's one thing that I noted down here that is new to me, and that always look for the mechanistic action of a biological process before you do anything. So it's the mechanism that is of interest. So Stelios, that's a beautiful teaching here. Thank you so much for sharing your wisdom. Thank you.
Can we have